Welcome to SIRT, Department of Mechanical Engineering, the SAGE Group. I am Dr. Amit Abbas, and this is brief description about my qualification. In the previous lecture, we have seen the introduction regarding the Pelton turbine and the complete setup of the Pelton turbine, how it will look like, how it can be operated, everything we have seen very clearly. Now, in this session, we will draw the inlet velocity triangle as well as outlet velocity triangle. How it looks like I already have discussed with you, but I also want to tell you one thing. Due to the symmetry of the blade, since once the water, when the water will leave the nozzle part, so this velocity is basically known as the absolute velocity when it leaves the nozzle, because the reference is the earth is also called as, this is called as the basic reference, means inertial frame of reference. I think this is also called as inertial frame of reference. While other, if when you will measure anything from the inertial frame of reference, it will give you the absolute value. So if to different object, if moving in either in same direction or in opposite direction, you will find the relative velocity. So you should know this concept, and on the basis of this concept, we are going to draw the velocity triangle. So at first, when the from here, if the water will leave through the nozzle, it will have the absolute velocity, and then when it will strike to the bucket, it will generate the relative velocity. And how it can be drawn, you can see here, this is velocity v1. Since from here the water is striking to the bucket, so this v1 is basically equals to vw1. This is also known as this u1 is the basically bucket velocity. Since bucket is also moving in the same direction, so this, when you will subtract the u1 from v1, you will get the relative velocity. Means the relative velocity between the water jet and what bucket. So the difference of these two velocities are known as the relative velocity at the inlet. And you should remember one very important point, that is the inlet velocity triangle is, I should not use the term triangle because it will be a straight line in case of Pelton turbine. So only single impulse turbine available is the Pelton turbine, and the inlet triangle will be a straight line in case of this Pelton wheel or Pelton turbine. But when from this splitter, when the water will strike, it will be splitted in two equal parts because of its symmetry of the bucket, and it will leave the water like this. Means the water will leave like this. And since the reference got changes from inertial frame to the moving part, so the leaving velocity will be relative velocity in this case. So the relative velocity is like this, as I am showing you the arrow. This VR2, and then this is U2 is the velocity of bucket. So the subtracting part will give you the VW2, and this velocity of flow is VF2 is always perpendicular to the this one, the bucket is in the initial part of the bucket, and here this is phi. How can you get the value of phi? This is basically 180 minus deflection angle. So 180 minus deflection angle give you the value of phi. So this is very basic idea or to draw the velocity triangle in case of Pelton turbine. What I am going to repeat it right now, and just focus here. At first, the water is leaving the nozzle. This is having a velocity v1, which is equals to vw1. I already have discussed each and everything during the class, So that's why it will help you to revise the things very clearly. And this u1 is basically what? This u1 is the bucket velocity. this VR2 is VR1, sorry, this is relative velocity. Relative velocity of water jet with respect to bucket. When it is leaving the bucket, the relative velocity at outlet is VR2, V2 is the absolute velocity of water at outlet, and U2 is the velocity of bucket, and VW2 again the same. This is a tangential velocity. VF1 is velocity of flow. Deflection angle is there, so you can draw the velocity triangle like this, and just draw it many times so that you will get habitual to draw it here. And while you will solve the problem, this will help you out very much. Because it is based on the velocity triangle, and you don't need to remember the formula while you will solve the question. So this is complete analysis of the inlet velocity triangle as well as the outlet velocity triangle in case of Pelton turbine. So thank you again on the behalf of the Department of Mechanical Engineering, SIRT and the SAGE group. I am Dr. Amit Awaz. Thank you once again.